Hello, today we're going to look at how to find the area of a regular polygon. I do want to remind you a regular polygon is a polygon that has all sides equal in length and all angles equal in degrees. We will be focused for this video and for this chapter on just regular hexagons, but the formula that we're going to talk about would work for any regular polygon. And that formula, the area is 1/2 times A times P. Now, A stands for the apothem. We haven't talked about that yet. I will show you what an apothem is in a moment. And P stands for perimeter. Now, be careful. Some students think AP just stands for apothem. The A stands for apothem, and that's multiplied by the perimeter of the polygon. So let's take a look at, I have a very poorly drawn regular hexagon. Bear with me. I put a dot here in the middle, that's called the center. If I draw a perpendicular line from the center to any side of this hexagon, that distance there is the apothem. It will split this side in half. So we're going to call this side S. These would each be half of that. And again, it is the perpendicular distance, so it will form 90 degrees with that side. We're also going to need to know what the distance is from the center to any vertex, and we're going to put that as an R. That's the radius of this hexagon. So if we know what our apothem is, and we know what one of our sides are, we can find the perimeter by just adding up all 6 of the sides. Or typically our perimeter here for a hexagon would be 6 times one of the sides. Another thing that we need to know for our hexagons here is what a central angle is. So if I take and draw another hexagon, it's a little bit better. Right down here, we're going to figure out what a central angle is. If I were to take this hexagon and draw all of the radii in there, I have formed 6 triangles. And if I'm looking for a central angle, it's one of those angles, and they would all be the same. So I know this would make a circle, which would be 360 degrees, but I'm dividing that among 6 congruent triangles. So that means that each of these central angles, boom, 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 would be 60 degrees. Well, you might be wondering why that's going to help you. Well, if we go back up above here, I can always find the apothem, the radius, and the side from using that triangle. And from what I know from my central angle, the whole thing here would be 60. That's going to make this part 30 degrees, and this angle here would be 60. And that's going to be a 30, 60, 90 triangle. And that's something that we have learned how to work with this year. Excuse me. So let's take a look at our first example. We're going to find the radius, the apothem, the perimeter, and the area of a regular hexagon
Mr. M. Kurtz, please call 6.
Sorry about that. With sides of 6, let's do 6 meters. All right, so we're going to be looking for 4 things. Let me go ahead and draw a pretty large hexagon. We know the sides are 6. We're going to put in our apothem and a radius, and we just said that the apothem and the radius are going to make a 30, 60, 90 triangle. Across from the 30 is a 1, across from the 60 is a radical 3, hypotenuse gets a 2. But this side here of this right triangle is not 6, it's half of that, so it's going to be 3. So I can divide in, 3 divided by 1 is 3, and multiply out. 3 times 2 would give me 6 for my radius, and 3 times radical 3 would give me 3 radical 3 for my apothem. So that's my divide in, multiply out. So on the side here, my radius is 6 meters. You will notice in a hexagon the radius and one of the sides will always be the same, but that only works for a hexagon. The apothem was the height over here. That's 3 radical 3 meters. The only other thing we wanted was the perimeter. Now the perimeter is the distance around this hexagon. I have 6 sides that are 6 meters, so that's going to give me 36 meters. When I add those all up, I could also take 6 times the number of sides. So now that we have all of that information, we can go ahead and use our formula to get our area. The area is 1/2 times the apothem times the perimeter. My apothem was 3 radical 3 meters. And again, that came from my 30, 60, 90 triangle that I formed. And then my perimeter was 36 meters. And now I can go ahead and multiply here. 1/2 times 3 times 36 is going to be 54 radical 3, that's square meters.